Welcome, ladies and gentlemen, to Integrated 2 Math. In today's episode, we will be discussing Chapter 9.4.1, which is inverse functions. The idea of the inverse function basically does this. What it does is it takes the roles of x and y and switches them. It's really just that. Now, there are a few more complications. I feel like I'm oversimplifying it with this definition here, and there are certain rules that go with what types of functions have inverse functions and which ones don't. But we'll go over all of that today. So, if I want to just talk about what inverse functions are and taking the roles of x and y and switching them at the most basic level, if I have a function, so I'll call him f of x, I will compare him to his inverse function here. Now notice the notation of the inverse function. The inverse function has that little -1 to the top, at the top of it. This is not read as f to the -1 power. It is not. It is read as f inverse. So I'll write that down. F inverse. I spelled that wrong. F inverse. Okay? So from here, if I give us the point 3 comma -5, remember, the inverse function takes the roles of x and y and switches them, which means the f inverse coordinate will be -5, 3. Just the same, if I go 4, 1, the inverse function will be 1, 4. So literally, you just take the x and y and you switch the points, and that's all you're really doing. So at the most basic level, inverse functions, they just take the x and y's and they switch them. So let's go ahead and keep that for now. That idea will come up again. So there are a couple of things about inverse functions that are really, really important. And for purposes of this class, we won't ever see this condition show up, but it's really good for you guys to know that way when you're reintroduced in Integrated 3, you will hopefully remember this idea. All functions have inverses. They all do. They all have inverses. But there's a problem. But not all functions have inverses that are also functions. So, what does it mean to be a function? Well, remember, to be a function is a relation between two. A function is a relation in which each input has exactly one output. Sorry, if I can type there. A function is a relation in which each input has one output. So, let's get an example in which we have a function, and then we graph its inverse, which no longer is a function. So let's talk about that. I will go ahead and do my little graph right here. Let's talk about y equals x squared, a common favorite among inverse function examples, and a new function in Integrated 2, so we have use for it. So I'll go and just label a few points here, and it's not super important that we do anything terribly accurate, but as long as we get the general shape, and as long as we understand how this graph works, then I think that we'll get the point here. So this is 2, 4, I'll call him, which means his symmetric buddy will be -2, 4, and then this will be 1, 1, -1, 1, and then 0, 0. So this is y equals x squared. So that's my function. And now from here, my inverse function, I'll do them in red. It's just going to be f inverse of x, and I'll say I don't know what he is. Well, what I'm going to do is I'm going to go ahead and do what I did above, and that is I'm going to take all the x's and y's, I'm going to switch their roles. So 0, 0, if I switch 0, 0, well, unimaginatively, I get 0, 0, so I'll just put a red x there to signify the inverse function. 1, 1 will do the same. -1, 1 will actually become 1, -1, so he'll go down here. This is 1, -1 now. 2, 4 will become 4, 2, which is right here, 4, 2. And then -2, 4 will become 4, -2. And what happens is that when I link up all the x's, I get this. And I'm dodging certain coordinates here because I don't want to have them overlap each other. But as you can see, this red function, or this red graph, is not a function. And I'm hoping you guys remember from integrated 1, because it doesn't pass this vertical line test, right? So this doesn't pass the vertical line test. And what does the vertical line test tell us? The vertical line test meaning there is more than one output for each input, right? I plug in a 4 and I get out a 2 and a -2, which is why the inverse of y equals x squared has an inverse, but does not have an inverse function. And that is because y equals x squared is not, I'll even give myself space there, y equals x squared is not a what we call 1-to-1 function. Now, what exactly is a 1-to-1 function? Let me just go and write in y equals, because x squared here is not a 1-to-1 function. A 1-to-1 function is a function. There's a lot of definitions here. A 1-to-1 function is a function in which there is only one way to obtain each output. So, a lot of words going on here, and I understand why you might be confused. Let me go ahead and cut this thing, actually. Rather, I'll copy it. I'm going to clear the board off, and I will explain through use of analogy what a 1-to-1 function is. I will show you what a 1-to-1 function is and what a 1-to-1 function is not. So we saw y equals x squared. I told you that that was not a 1-to-1 function. Okay, so I'll even put not 1-to-1. And that's because he grew out like this. We saw that. I'll even go ahead and use this point here that we did last time, 2, 4. I'll go ahead and compare him to y equals 2 to the x, which is an exponential graph, which is what you guys actually do remember from integrated 1. And if you remember from integrated 1, he looks kind of like that. And I will go ahead and plug in a point here. Let's say I'll plug in a point, how about 2, 4? 2, 4. So let's compare and contrast these. Why is 2 to the x 1-to-1 and x squared not 1-to-1? Well, remember, a 1-to-1 function is a function in which there is only one way to obtain each output. Is that true for x squared? Is the only way I can obtain 4, right? This output, 4, is what I'm trying to obtain. Is there another way that I can obtain this value? Well, of course there is. I could have plugged in -2 and gotten out 4. But in the case of y equals 2 to the x, is there another way I could have gotten out 4? Well, what happens if I let x equal -2? Okay, well, let x equal -2. Well, y equals 2 to the -2. That's 1/4. So that's like down here. This is -2, 1/4. So based on this graph, I feel like there's only one way I can get that 4, and that's if I plug in 2. That's why it's known as 1-to-1. One input, one output, and there's only one way to get each output. So oftentimes the visual gimmick, like you guys saw in integrated 1 with the vertical line test to determine functionality, is the visual marker for determining a function's 1-to-1-ness is a horizontal line test. So a horizontal line test determines a function's 1-to-1-ness, if that's even a word. So notice how a horizontal line touches this parabola twice. That means that we are not one-to-one, which means our inverse will not be a function. If I draw a horizontal line anywhere on this exponential, it only touches once. So this is 1-to-1, meaning its inverse is in fact a function. And you will learn all about this guy's inverse in Integrated 3, and you will love it. Okay, let me go and clear off the board, and I will get started with some actual examples. Okay, here we go. After all that exposition is over, I will tell you that at this level in Integrated 2, you will not be encountering one-to-one functions and stuff like that. That's more reserved for Integrated 3, and they will get into more depth as you move forward through that class. But we're going to find the inverse of this function. So I'm going to say, hey, what is f inverse of this thing? I have no idea. Well, remember, what does an inverse do? At the very beginning of the video, we talked about an inverse being taking the x and y roles and switching them. So the first thing, whenever you are asked to find the inverse of a function, the first thing you want to do is switch the x and y. And then what you do is you just get y by itself. That's all you do. You just have to solve for y now. So I add 7 to both sides, so x plus 7 equals 2y. Divide by 2. Now y equals x plus 7 over 2. Now I'm actually okay with this answer, but if you are asked to graph this thing, it might not be a bad idea to see this as a separation of the fraction, where at the end you will call it 1/2 x plus 7 over 2. I will take either iteration. I'm not totally concerned about it. So there you go. Here comes another example. Let's say f of x is equal to 5x minus 15. Well, notice how it's called f of x this time, and it's not called y. Very easy solution. Remember, f of x, g of x, k of x, they're all synonymous with outputs, so you can just, for simplicity's sake, call him y. And that allows you to be back in a comfortable position where you switch x and y. And you get x plus 15 equals 5y. Divide by 5. And you get y equals x plus 15 over 5. But I would rather you call him f inverse. That way we can keep things clear. And if you want to, go ahead and separate it out. And you can separate it out like that. So for all my exposition, inverse functions at their procedural level are quite easy. Conceptually, they're a little harder though, so I will let your Integrated 3 teacher and your Honors Pre-Calc teacher deal with that. But at the procedural level, it's pretty simple. You switch x and y, get y by itself. And so hopefully that makes sense. As always, please leave comments or questions in the comments area, and I will see you in the next episode.